Example 8.6 Part B still wants us to solve the system by the addition-elimination method. And this time, we're going to end up seeing that we're going to need step number 1 from the procedure. So indulge me for a moment. Let's say that we wanted to immediately jump to step number 2, like we did on example 8.6a. Well, if I do that, things are lined up correctly. So 5x and 2x would make 7x. 3y minus 10y will be negative 7y. And then negative 16 plus 30 is going to be 14. And what you should notice is that none of the variables end up eliminating in this process. Now we do get another equation, and this equation is different than either of the two that we started with, but you still have two variables. And so this ends up being an unproductive addition. So we are not going to be able to immediately start with adding the equations like we did on 8.6a. So let me erase this. This is not going to work. So since this isn't going to work, we're going to have to do the rewrite and multiply phase. So I'm going to make a suggestion here. I'm going to multiply the entire top equation by negative 5, and I'm going to multiply the entire bottom equation by 2. Now I can do this because if I'm multiplying the entire equation, then that means I'm multiplying both sides of that equation, so everything should still be balanced. And since these two equations are independent, then it should not matter that I'm using a different number for the two different equations. They'll be the same. So I'm going to rewrite the first equation. It's now going to say negative 10y, or excuse me, negative 10x minus 15y is equal to positive 80. And the second equation, we'll rewrite it as well. It's going to give me positive 10x minus 20y is equal to 60. And this is the versions of my equation that I want to be able to do my addition with. So I want you to notice why I chose negative 5 and positive 2. When I go to add my x's now have a 10 for their coefficients, but one of them is negative 10 and the other is positive 10. So when I add them, they will eliminate. So we can force the elimination to occur by making an appropriate multiplication before we go on to the addition of the equation steps. So that means that you have to make a decision. You either try to eliminate the x or you will try to eliminate the y. And it does not matter which one, because you'll always do that back substitution step to find whatever the other variable is that you don't have. So pick a variable, try to make it eliminate, and then we're going to end up in this example with negative 35y equal to 140, and then that would result in y equaling negative 4. So we'll go through the back substitution phase. Let me go back over here to the original equation 1 and equation 2. I'm going to pick equation 1, 2x plus 3y equals negative 16. We saw that it does not matter which one we go back substitute in, so we'll just pick the one that looks the easiest, and we'll substitute in negative 4 where we have y. So 2x plus 3 times negative 4 should equal negative 16. So 2x minus 12 will equal negative 16. 2x would then equal negative 4, so therefore x must equal negative 2. So our proposed solution is the ordered pair negative 2 comma negative 4. And I'd like to check that. Go back to equation 1. 2x plus 3y equals negative 16. 2 times negative 2 plus 3 times negative 4 is supposed to be negative 16. Let's see if it is. Negative 4 minus 12 And we do. We get negative 16 equals negative 16. So the first equation checks out. Let's try the second one. 5x minus 10y equals 30. 5 times negative 2 minus 10 times negative 4. So that's negative 10 plus 40, which does get us 30 equals 30. So they both check out. Make this our solution set and box it our answer.